Good morning students. As you can see that today I have so many chemicals in front of you. So now you can get an idea that today we are going to perform an experiment that is given in your syllabus. The first experiment that I am going to perform that is a copper sulfate solution and iron. That is the most common example that we have come across in class 7, that whenever we place an iron in copper sulfate and we know what happens. Today we are going to perform that. So let's see. So you can see that there are so many chemicals. Just have a look with the chemicals and the materials that are present in front of you, because these are very vital chemicals that will be required for the experiment. So let's start with the first. The first, I have taken a copper sulfate, and in a copper sulfate you can see blue crystal copper sulfate, and in a blue crystal copper sulfate I have already made a copper sulfate solution. Now there is iron powder, here it is. So I am going to add iron powder over here. I am taking it and I am adding to the copper sulfate solution. Now see, this reaction is very slow. It cannot happen instant. So I have to wait for an hour, or at least I have to wait overnight to see the change. So students, after keeping that copper sulfate and iron solution overnight, we are back to see the change. Now I am removing the lid to see what surprise is left behind. This is magnesium ribbon, as you can see, and in a magnesium ribbon just I am burning it. Let's see what happens. What we got after burning. So see carefully see the change. So this is magnesium, the gray color magnesium, and this is, you can see, it is a white colored powder. Now what is this white color powder? We all know this is a magnesium oxide, right? Now we know this is basic in nature. Now I am going to add a little amount of magnesium oxide. We know it will get dissolved. So let's see if it gets dissolved or not. So I'm shaking it constantly. So I have to constantly stir it. Just wait for 5 minutes. We have dissolved them in a water, and you can see it is completely dissolved. Now let's taste the basicity. So this is the red litmus paper in your hand. My hand is quite wet, that is why you can see it is wet. So let's dip into this solution and see and taste their basicity. Can you see the change? Carefully see the change. See? It has turned to blue. It has turned to blue. So what does it mean? That the magnesium oxide that has been dissolved in water is basic in nature. Now let's move on to the next, that is addition of a zinc in a hydrochloric acid. Now in the class, as you can see in school, this zinc is not available, but instead there is iron is available. And you have learned in a class 8 that iron, metal in presence of acid, produce salt and hydrogen gas. Right or not? Yes or not? So instead of zinc, we are performing it with the help of irons. So let's see, will it happen? So I am taking an iron. So let's take dry test tube. So here is I have taken, since I am working with a one hand, it is impossible. So here you can see I am taking a test tube, and instead of spatula I am just going to add directly to the, let's add directly to the, yes, okay. So add, this is a hydrochloric acid. Now I am going to add the hydrochloric acid drop wise. Now in order to, you have to use dropper for it. Remember, dropper is very necessary. Don't handle the acid with the bare hands. So let's see. Can you hear? So students, as you can see in front of me, there is two compound present. One is barium chloride, another one is sodium sulfate. So let's study. Now in order to do this, we have, you know what kind of reaction we are going to perform over here? We are going to perform a double displacement reaction. You have come across displacement reaction, right? But you haven't never come across double displacement. Today we are going to do that. So let's see what happens in the double displacement reaction. So let's do. I have taken, so I have already made a solution of a sodium sulfate here, and it is a barium chloride. And you know, barium sulfate is insoluble in water. So that means that after, in a double displacement reaction, after mixing, there should be insoluble white precipitate at the bottom of the test tube. So let's see. Now I am adding barium chloride solution to the sodium sulfate. Slowly. Can you see? Have you observed that? Instant formation of white insoluble substance. So this kind of reaction is a double displacement reaction. Okay? Students, as you can see, I have taken a copper sulfate in a test tube. Now let's heat it. Can you see water droplets over here? And it is turning, blue color is turning white, and the water droplets is present at the surface of the test tube. That means, you know what? The copper sulfate contains water inside the geometry, and that water is being released upon heating. And whenever the water is released, it turns white, as you can see over here. So you can see a single drop of water turn anhydrous white color copper sulfate again to regain its blue color. Is it interesting? Right? So you can see that after, so these kind of compound, do you know any compound which is having a water inside their geometry, we call them a water of crystallization, and after losing a water, you can see they have turned white, but after adding a water, they again have regained their own color. So now what if I heat this copper sulfate very strongly? The copper sulfate has turned black. Do you know why? The reason is because the copper sulfate is decomposing to copper oxide, and that copper oxide is slightly blackish or brownish in color, you can see.